Hi, I'm Randall Heyman, a university mathematics academic. Welcome to my Corona Help playlists, where I help students and educators with quick turnaround videos during the coronavirus outbreak. If you'd like me to make a video for you, then just comment below any of my videos or drop me an email. So someone in the US has asked me this question. So let R be a poly ring with a constant term divisible by divisible, I think that should have, I think it actually said divisible in. So what is this ring? Let's just put this R equals the set of F that are elements of ZX, such that now the constant term we know is, we can get the constant term by just putting F0. So I suppose actually I could just put 7, I could use this notation, 7 divides F0. Okay, so the next sentence is, it's got this thing here. Now, 1, what does that mean? You need to be a little bit nuanced with the notation here. If you mean this, so this is a set that just contains one element, the element 4x cubed minus 21. Well, that is not an ideal. Why? There's no additive identity. Which is that special number, which is, well, let's just go back a step. This ring here, up here, let's go. So the ring is actually this, and we're using addition and multiplication as the two operations, and they're just the normal operations of adding and multiplying polynomials. So when I say no additive identity here, what I'm saying is that there's not that special element 0, which is special because when you add it on to any element, it doesn't change it. So in this set here, we don't have a 0 element or an additive identity. Now, some of you will have been following my videos on ideals and rings, and you'll see that there are 4 things. In the way I explained it, there were 4 aspects to ideals. One was that it was closed under subtraction. So, i.e., what do I mean by that? I mean that if we take 4x cubed minus 21 minus 4x cubed minus 21, well, that's not an element of the set. I'll just go back here. It's not an element of S. Okay, so we've quickly disposed of that one. Now, the next thing is the normal notation for what I think the writer wanted is this. It is acceptable to do what he wrote, but this is normally the best. This is the set, or the ideal, generated by 4x cubed minus 21. So that is equal to, what's that equal to? The set of 4x cubed minus 21 times g of x, where g of x is an element of R, that ring. So it's all multiples of 4x cubed minus 21. Now, and I suppose we could put, once again, addition and multiplication as the 2 binary operations. Now, this is called a primary ideal, which gives away that it's an ideal. But if you wanted to do it properly, you would look at my 4 rules that I gave. So rules, and you just satisfy yourself that that is that it satisfies these 4 rules. So the rules for ideals, I don't think, unless anyone wants, I'm not going to do these in full detail. One, subset, S is a subset of R. Well, that's true. This here, this is a subset of R. 2, S is non-empty. Well, that's true because if we go here, we can see that this certainly contains 4x cubed minus 21, but it also includes 0. It also includes 8x cubed minus 42, so it is non-empty. Closed under, this is a bit unusual the way I do it, but at the time when we were explaining ideals was the best way to do it, I thought. Closed under subtraction. Subtraction. So what we're saying there is that if we subtract any 2 elements, then we stay, the result is in S. In other words, A minus B is in S for all A and B. Essentially what that all does is that what's this doing? It's really ensuring that there must be a 0 because we can have A minus A. There must be a negative. It must be commutative because we can change the order around. So it sort of satisfies a whole lot of conditions in one. And the fourth, which is really that main ideal condition, is that S is closed. I haven't actually expressed it this way before, but I will this time because it's a nice way of expressing it. Is closed under multiplication by the ring. So what that's saying, the ring R. So what that's saying is that if we take any S, so S, whoops. So if we have a little s, we have an element in S, and we have an R in the ring, well then S times R has to equal R times S. Has to be in, not the ring, it has to be in S. And if you work through this one up here, this definition, you'll see that that's satisfied. If we take any element, how did we construct this? Well, we basically took this 4x cubed minus 21 and multiplied it by every element in the ring. And so that essentially we've defined that as being S. And so the definition actually basically outlines the idea that it's closed under multiplication by the ring R. So what we would then conclude is that, so here we would just say finally that, so S is an ideal of R. Now the third thing is, you will, look, I think it is acceptable to go like that. In other words, a curly bracket for an ideal, but it's better to use these sort of brackets if you want to indicate something being generated by an element or elements. Okay, so I hope that's helped. If you've got any questions on any of that, by all means, please comment below any of my videos, or you can drop me an email at coronahelpmathematics@gmail.com. And the same applies for any aspect of mathematics. If I think I can help you, I will do so.